Hello everybody, Leanne here, and welcome back to another mathematics video. In this video, we will be solving linear equations using the graphical method. So this method combines some concepts that we already know. For example, we already know to draw the equation of a straight line, and we already know when we solve simultaneous equations, we get an x value and a y value. Well, if the values are x and y, but we get two values. So when we are solving graphically, you will get two answers as well, and you'll see how we'll get the two answers graphically. So let's head into this. So the first things first, in coordinate geometry, we can solve a system of linear equations by graphing each equation on the same coordinate plane. And after you finish graphing these two equations, the point at which these two lines, because it's a linear, the point at which these two lines intersect, that point will be the solution. And of course, we know at a point we will get an x value and a y value. And of course, at the end of this, you can substitute these two values into both equations and they should satisfy them. If not, if they don't satisfy, that means you did something wrong with your graph and you need to recheck. So let's head straight into the first example. So we asked to solve this equation graphically. So the first equation is y equal 2x plus 1, and the second one is y equal negative x plus 4. So let's head into our graph. So let's deal with the first equation, which is y equal 2x plus 1. So we know for this 2, we know that 2 will be the gradient and the 1 will be the y-intercept. In other words, the point at which the graph or the line crosses the y-axis. So the x, the coefficient of x, which is 2, is the gradient. So we know 2 would be the same as 2 over 1. And this 2 will be the rise and the 1 will be the run. So of course, we need to start from one point and then we can use the gradient to get the other points on the line. So let's start with the y-intercept, which is 1. So we can go and plot a point at 1 and then we can use this point to get the other points. We can use the gradient now to get the other points. So you know it's simply rise over run, so the rise is 2. So we go up 2, 1, 2, this will take us to 3, and then we go across 1, which will take us to this point. And we can continue again, we can go up 1, sorry, not 1, we go up 2. So this will be 1, 2, and then we go across 1, and this will be the other point. And then we can go again, 1, 2, and we go across 1. This will give us the other point. And now we can use these points to draw the straight line. So let me draw in this straight line. So I'll use a ruler, but in this case, for demonstration, I'll use a straight line from the computer. So I'll pass through all the points. So we have our line passing through all the points, and then we now move on to the second equation, which is negative x plus 4. So let me just write that. So this will be y equals negative x plus 4. So we see 4 will be the y-intercept and the gradient will be negative 1 in this case. So we know negative 1 is the same as negative 1 over 1. So the rise will be negative 1 and the run will be 1, positive 1. So we need a point to start at. So we'll start at the 4. So 4 will be the y-intercept. So we start at the point 4. And then we now use the gradient to find the other points. So it's negative 1. So that means we're going down 1 and positive 1, we're going across 1. So here would be the other point. And then we can go down again, go down 1, go across 1. Here would be the other point. You go down 1 and go across 1. Here would be the other point. And then we use our ruler to connect the points. And here we have our two lines. And of course, as I said initially, at the point of the intersection of the two lines will be the solution. So in this case, we can see the two lines intersect at this point. So at this point, we take the coordinates for that point. So the coordinates for that point would be, let me see, we go across 1, so positive 1 and 3. So 1 and 3, and that will be the solution of the pair of linear equation. So of course, we can substitute these two values into the equation to see if they satisfy. So the solution will be 1, 3. So of course, this 1 would be the x and the 3 would be the y. So let's go back to the equation and check to see if our answer is correct. So it's 1, 3. So the solution will be 1, 3. So let's take the first one. So y equal 2x plus 1. So we see x is 1 and y is 3. So we'll have 3 is equal to 2 multiplied by x, which is 1, plus 1. So 3 would be equal to 2 times 1 is 2. 2 plus 1 is 3. So yes, that checks out. And let's try the other one now. y equal negative x plus 4. So we see y is 3 and negative x would be negative 1 plus 4. So 3 will be equal to negative 1 plus 4. So hence 3 is equal to 3. So that satisfies as well. So yes, we know our solution is 100% correct. So of course, we cannot stop there with one example. Let's go into another one to cement this concept. So let's look at our second example. So this example says, solve the following systems of linear equations graphically. So we have the first equation, which is y equal x plus 2. And the second one, y equal negative 2x plus 5. We're asked to solve this equation graphically. So of course, we go and plot and draw the first equation. So let's represent that on the graph. So this will be y equal x plus 2. So of course, in this one, we see the gradient would be a positive 1, which would be the same as 1 over 1. And the y-intercept would be the 2. So we start with the 2, we go at the y-axis and we plot the point at 2. So here we will put the point. So that is the point at which the line will cross the y-axis. And then we use the gradient to find the other points. So we go up 1 and we go across 1. This is easy to do. So we go up and we go across 1. We go up and we go across 1. We go up and then we go across 1. We go up and then we go across 1. We can go on, but we have enough points to draw our line. So we use our ruler and we draw our line. And then we use the second equation to draw the other line, which is y equal negative 2x plus 5. So we have y equal negative 2x plus 5. So we see the gradient would be negative 2. So that would be the same as negative 2 over 1. And the y-intercept would be a positive 5. So we start off with the point 5. So we draw in our line. So we go up. In this case, it's negative 2. So that means we go down. So we go down 2 times. So we go down 1, 2. And then we go across 1. So here would be the first point. And then we go down 2 times again. 1, 2. And then we go across 1. Since it's a positive 1. And here would be the next point. And then we go down 2 again. Doop, doop. And then we go across 1. So here would be the next point. And we have enough points to draw our line, so we use our ruler and we draw in our lines. So in this case, we see the lines intersect at this point. So we see the coordinates of that point. So we see we go across 1 and we go up 3. So the coordinates at that point would be 1 and 3. And that will be the solution to this pair of equations. So of course, we need to check to see if it satisfies the equation. So we go back to the original and we check. So we see the solution is 1, 3. So it's 1, 3. So we have the first equation, which is y equal x plus 2. So we substitute the 1 into the x, because we know the 1 is x and the y is 3. So we substitute the 1 for the x and the 3 for the y. So the 3 is equal to 1 plus 2. So 3 is equal to 1 plus 2. The 4 gives you 3. So we see that satisfies. And we go to the second one, which is y equal negative 2x plus 5. So we see y would be equal to 3. And this will be negative 2 times x, which is 1, plus 5. So 3 would be equal to negative 2 times 1 would be negative 2 plus 5. And negative 2 plus 5 will be equal to 3. So 3 is equal to 3. So that checks out and that checks out. So our solution would indeed be 1, 3. So we see when we want to solve simultaneous equations graphically, we need to graph each equation on the same Cartesian plane, and then the point at which the two lines, in this case, since we're dealing with linear equations, so we see the point at which these two lines intersect. That point will be the solution to the pair of equations. And then you can do the final check to substitute these 2 points into the original equations and to see if they satisfy. As long as they satisfy, you know that you plotted correctly, you drew the diagram correctly, and you're on your way to getting all of your marks. So of course, we cannot leave here without giving you a few ones for you to try on your own. So here we have a list of questions that you can do on your own. Make sure you have your graph paper, your pencil, and your ruler to draw and plot your graph, and then you want to check at the end. So with that, it brings us to the end of this video, and I trust that you have a good understanding of how to solve simultaneous equations graphically, and I'll see you in the next video.